Given that sine theta is 5 over 7, that theta is obtuse, find the exact value of A, cos theta, and B, tan theta. Now there are several different methods of doing these. I'm going to show you two, and you can use mixtures of the two as well. So method 1. Method 1 uses the Pythagorean identity, sine squared theta plus cos squared theta is equal to 1. And because I want to find cos, that's cos squared theta will be equal to 1 minus sine squared theta. So therefore cos squared theta will be 1 minus 5 over 7 squared, which gives me 1 minus 25 over 49. And then 1 is 49 over 49 minus 25 over 49. Same denominator now, so 49 minus 25 is 24 over 49. And that gives me that cos theta, if I take the square root, plus or minus square root of 24 over 7. Now the problem, is it positive or is it negative? Well, one way to do it, just before we do that, we should simplify root 24. Root 24 can be written as the square root of 4 times 6, and the square root of 4 is 2, so that becomes 2 root 6. So this becomes plus or minus 2 root 6 over 7. Now going back to that question, is it positive or is it negative? Well, one way to do it is to consider the graph. This is the graph of cos, so you need to know the graphs. What is an obtuse angle? An obtuse angle is between 90 and 180, so let's just mark that bit on the graph. And we can see for cosine between 90 and 180 that the actual value of cosine will be negative. And therefore we say that cos theta will be minus 2 root 6 over 7. In the next method I'll show you another way of doing that as well. Then we use the idea that tan theta is sine theta over cos theta. So tan theta will be 5 over 7 divided by minus 2 root 6 over 7. So we take our answer from there. When we divide fractions, we multiply by the reciprocal, so it becomes 5 over 7 times 7 over 2 root 6. The 7s will now cancel out. Don't forget the minus sign is still there, so we get tan theta is minus 5 over 2 root 6. Again, we don't like the square root sign to be in the denominator, so we rationalize. So take the square root of 6, and then we have to multiply the numerator by the square root of 6. So it's going to give me minus 5 root 6. Root 6 times root 6 is 6. 6 times 2 gives me 12. Okay, that's one method of doing that. The second method is, remember, we want the sine theta is 5 over 7, and we know that theta is obtuse. So it's to draw a right angled triangle, label it opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse, so the opposite side is 5, the hypotenuse is 7. Now we can find that the adjacent side by using Pythagoras' theorem. So the adjacent squared will be 7 squared minus 5 squared, because the adjacent is one of the smaller sides. 7 squared is 49, 25 squared is 25, that gives me 24. The adjacent side will be the square root of 24, which again will be 2 root 6 when you simplify it like in the previous example. So that's 2 root 6, right. Now you can say that cos theta is adjacent over hypotenuse, and that tan theta is opposite over adjacent. So that will be, for cos theta will be 2 root 6 over 7. And for tan theta is opposite over adjacent, so it's going to be tan theta is equal to 5 over 2 root 6. Now, the problem is, are these positive or are they negative? Because we know that the angle is obtuse. So, however, theta is obtuse, i.e. between 90 and 180. If we draw what's known as the unit circle, remember with the unit circle when we produce the graphs, we go around this way, anti-clockwise. So this is considered to be the first quadrant. This is considered to be the second quadrant. This is considered to be the third quadrant. And this is considered to be the fourth quadrant. Now this is sometimes known as cast. Now if we remember, in the second quadrant, sine is positive In the first quadrant, they're all positive. In the third quadrant, tangent is positive, and in the fourth quadrant, cosine is positive only. So to repeat that, in the first quadrant, all three ratios are positive. In the second, sine is positive. In the third, tangent is positive, and in the fourth, cosine is positive only. Right, the obtuse one, it will be in the second quadrant because it starts from 0 here, 90, 180, 270, 360. So going up to here, this second one will be where the angle is obtuse. Therefore, we need to consider the second quadrant. So we start our angle here, and we go round and draw a line up here. These tell us in which quadrant each ratio is positive. So first, second, third, and fourth. Right, so the only sine is positive in the second quadrant. That means that both cosine and tangent are negative. So in the second quadrant, both cos and tangent are negative. Therefore, cos theta will be minus 2 root 6 over 7. So we just put a minus sign in front of that. And that tan theta will be minus 5 over 2 root 6. Again, you'd have to rationalize by multiplying by root 6 over root 6, which gives you minus 5 root 6 over 12. So the same answers as we did it the first method. Now what you need to do is choose a method, and you can use mixed method. You could use the graph here if you wanted to, or you could use this in the first method and work with it and use the method which works for you. I hope you've understood, and I thank you very much for watching.